Fault detection and diagnosis in UAVs are crucial for safety and operational efficiency. Issues can arise from electronic, mechanical, or software components, as well as external factors like weather conditions. Classification of UAV faults. Faults can be categorized into several types. Mechanical faults: motors, propellers, frames, pivots. Electronic faults: battery, ESC, IMU, GPS, barometer. Software faults: corrupted firmware, calibration errors, connection loss, communication issues, weak radio signal, interference, telemetry loss. External factors: strong wind, rain, electromagnetic interference. Mechanical faults and diagnosis. Motor issues. What are the symptoms? The UAV does not take off evenly. A motor stops during flight. Strong vibrations during acceleration. Burning smell or overheating. Possible causes: weak connection between the ESC and motor. The motor is blocked by debris or dust. Worn bearings due to friction. Cracks in the drone's arms. Diagnostic methods: individual motor testing with a multimeter. Diagnostic methods: individual motor rotation check, using an oscilloscope to inspect motor signals. Propeller faults. Symptoms: unstable or oscillating flight. Abnormal noises, buzzing, or vibrations. The UAV spins uncontrollably. Possible causes: cracked or unbalanced propellers. Incorrect propeller installation or angle. Dirt buildup on the propellers. Diagnostic methods. Visual inspection before each flight. Propeller balancing test. Replacing propellers and comparing performance. Frame and arm issues. Symptoms: the UAV tilts in one direction without explanation. Unusual noises during flight. Loose or cracked drone arms. Possible causes: hard impacts during landing. Material wear over multiple flights. Loose or missing screws. Diagnostic methods: detailed visual inspection. Tightening all screws and connectors. Ground testing before takeoff. Electronic faults and diagnosis. Battery issues. Symptoms: the UAV suddenly powers off mid-flight. Reduced flight duration. Excessive battery heating. Possible causes: defective or swollen battery cells. Loose or corroded connectors. Overcharging or deep discharging. Diagnostic methods: battery testing with a voltmeter, checking cell voltage with a LiPo tester, inspecting for swelling or leaks, an observation of swelling or fluid surges. Defects in the IMU. Symptoms: the UAV has unpredictable movements. The drone does not maintain stability in the air. Frequent calibration errors. Possible causes: strong vibrations affecting the IMU. Temperature errors. Improperly heated EMU. Corrupt firmware. Diagnostic methods: calibrate IMU through the drone software. Monitor telemetry data. Apply a vibration filter to protect the sensors. GPS and barometer issues. Symptoms: the UAV does not maintain GPS position. Errors with return to home, RTH. Fluctuating altitude without reason. Possible causes: faulty GPS antenna or blocked by metal objects. Strong electromagnetic interference. Barometer not protected from air currents. Diagnostic methods: test GPS signal in an open area. Protect the barometer with a sponge or appropriate housing. Check RDH settings before flight. Software and communication defects. Firmware or calibration issues. Symptoms: the UAV does not respond correctly to control commands. Error signals in the flight app. Unstable drone behavior. Possible causes: outdated or corrupt firmware. IMU or ESC calibration errors. Problems in configuring the flight control. Diagnostic methods: update firmware to the latest version. Reset settings and recalibrate. Test in a flight simulator before takeoff. Communication problems between UAV and remote control. Symptoms: sudden loss of signal. Lag in control responses. The UAV enters fail-safe mode, automatic return. Possible causes: radio, Wi-Fi, GSM tower interference. Weak battery in the remote control. Faults in the radio receiver. Diagnostic methods: test the remote control at short and long distances. Change the communication frequency. Avoid areas with strong interference. External factors that may cause defects. Strong wind affects stability and may overload the motors. Rain or humidity may damage the electronic circuits. Excessive heat may overload the motors and battery. Electromagnetic interference affects GPS and radio communication. In conclusion, fault detection and prevention are vital for UAV safety and performance. General inspection. Visual inspection and component testing before each flight. Active diagnosis. Using telemetry and sensor tests to prevent failures. Proper maintenance. Cleaning motors, calibrating sensors, and updating firmware. A well-maintained UAV is a safe and efficient UAV.